Okay, here's number 14. When I was doing this, I thought this was a pretty tough problem, so I'm making this a calculator problem for sure. First thing, this shape, trapezium, we need to be able to show that the area is something. So what the heck is the formula for the area of a trapezium? So if I look on my formula packet, look, it uses the word trapezium, and it gives me a formula. So I know the formula for the area of a trapezium is 1/2 A plus B times H. Okay, so now you got to kind of figure out what do those mean. A plus B are the two bases, so A plus B, and H, of course, is the height. So we need to figure out some expressions for the this base and for the height. We don't have any expressions for those. The only thing that I have is I have theta and I have 2. So notice we're trying to show that it's equal to this, and it has a theta and it has some multiples of 2 in it. So chances are that's going to help us out. So I'm going to go ahead and do, what can I do? I've got a little right triangle here. So I could write an expression for this right here. I know that cosine of theta is equal to, I'm going to call this x, is equal to x over 2, adjacent over hypotenuse. So if I solve for x, I get 2 times cosine theta is equal to x. Okay, this is also going to be x with the same angle and the same side. So this is also going to be x, and I know this is going to be 2. Therefore, this entire base here, I'll call this base B, is going to be equal to 2x, x plus x is 2x, plus 2. Okay, so now I have an expression for this base, but I can't use x, I have to use theta. So I'm going to plug in where the x is, I'm going to plug in this. So my base, my B, is going to be 2 times 2 cosine theta plus 2. Right? So there's my bottom base. So let's see what I've got so far. So area is equal to 1/2. A is this side, so that's easy, 2, plus B, this was the hard side, that was this, times 2 times 2 cosine theta plus 2. Okay, so I've got my A, I've got my B. Oh, now I need the height. So the height, I'm going to call that y. So to get y, that would be opposite over hypotenuse. So I could use sine. So sine of theta is equal to opposite over hypotenuse. Solve for y, I get 2 times sine theta is equal to y. Y is my height. Actually, you can just make that h. So that's my h. So that's going to go here. So that's 2 times sine of theta. Okay. Now I'm going to try and simplify this because I'm trying to get it down to look like this. So I'm going to simplify inside these parentheses first. So I have area is equal to 1/2. 2 plus 2 is 4. Now I'm going to distribute this. I'll just multiply that. 4 cosine theta. Okay, so I did that. And that's times 2 sine theta. How am I looking? Does it match yet? No. All right, let's distribute the 1/2. So I get area is equal, half of 4 is 2 plus 2 cosine theta. All of that times 2 sine theta. Does it match yet? No. So let's distribute again. So I'm going to distribute this way, 2 sine theta. So I'm going to get 2 times 2 is 4, so 4 sine theta, plus 2 times 2 is 4 cosine theta sine theta. Hey, now it's starting to look good. This matches this term right here, but this does not match that. Notice this says 2 theta, and I have cosine times sine. So this is where I want to get out my formula packet and go, is there a formula that's going to help me out? So I'm going to go find my trig formulas. And there's actually some trig formulas on here that we didn't talk about, but we can still go ahead and use them. I actually looked up how to prove these formulas, and it's brutal. The proof is insane. If we have time, we'll do it next semester. But for right now, we're just going to see if we can replace something here. So notice I have cosine times sine right here is equal to sine 2 theta. And notice I want a sine 2 theta in the problem. So I'm going to I need to find a 2 sine theta, cosine theta. So this right here can be rewritten. So 4 sine theta plus 2 times 2. And I'm going to go ahead and switch the order so it exactly matches what I have in my formula packet. Using the property of multiplication. Now this can be replaced with 2 sine theta. So I have area is equal to 4 sine theta plus 2 times sine of 2 theta. And now it matches, right? Yes, it matches. All right, so that was pretty tricky. Okay, Zoe wants a window to have an area of 5 meters squared. Find the 2 possible values of theta. So this is the area. We want this to equal 5. So I want 5 equal 4 sine theta plus 2 sine 2 theta. Okay, so this is where we're going to use our calculator. So I am going to put in 5 for one of my equations, and for the other equation, I'm going to put in 4 sine theta plus, oops, got to close my parentheses, very important, plus 2 sine 2 theta. All right, let's graph that, see what it looks like. There is my 5, and here comes my function. Ooh, interesting. Okay, so I want the 2 possible values for theta. So I want the 2 intersections, and notice back in the beginning it said theta needs to be between 0 and pi over 2. So I'm going to go check my window, and I'm going to make sure my x goes from 0 to pi over 2. Divided by 2. And notice I already had in here that I was doing my scales, my tick marks by pi, but maybe I'm going to change that to pi over 4. An intersection and another intersection. Okay, so it's kind of hard to see those. I could change my y's from 0 up to 5 or 6 or 7. How about 7? Okay, so there's my 5, and then here comes my graph. So we're going to be using our graphing display here to get these answers, so that means I want to sketch what I see. So I'm going to, what I'm doing is I'm using my graph. I have my line 5, this is y 5, and then I have my other line going like this, and we're looking for these intersections. So this is y equals 4 sine theta plus 2 sine 2 theta. Okay, so now I'm just going to use my graphing display calculator to find the intersections. That's option 5. I hit enter, 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 and it tells me the first one is theta is approximately equal to 0.856 if I do 3 significant figures correctly. Then I got to do it again. Intersection, go over to the other intersection, enter, 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 and I get 1.25. 1.25. So there are my 2 possible values for theta. Oh, and the lights just went out. There we go. All right, next thing. John wants 2 windows that have the same area but different values of theta. Find all possible values for the area, which have the same area but different values of theta. So I had a really difficult time with this question. What I did, I'm trying to think, how did I do this? What did I do? I don't remember how I got the answer. So the answer is the area has to be between 4 and 5.20, and oh, I remember. Okay, So I got the upper limit by finding what's the maximum area that we could get. So the maximum area, so if I calculate this and I go to my maximum, and I need the left bound, oops, notice I'm on the wrong curve, so I'm going to use the up and down arrows to get to the right curve. Now I'm on the right curve, move to the left of it, move to the right of it, enter, enter, and it says my y value, that's what I'm interested in, because the y value is the area. The top is going to be 5.196, so that rounds off to 5.2. So that's how I got this value. And then I was thinking the smallest value was going to be 0, but I looked up the answer on the IB website, and it said the answer was 4, and I don't know how they got 4. Because they say my theta has to be between 0 and pi over 2, so, yeah, I don't know. I don't know how they got 4. So I'm just going to give up on that one for right now. I think the answer should have been 0. The area is going to be between 0 and 5.2, but I really don't know. So if anybody figured out how they got 4, I was thinking that the area would be 0. So if anybody can figure that out for me, why would the lower possible area be 4? I would love to know about it. Alrighty, that's that.